Let's talk about writing a polynomial given the zeros. We've done one like this before, but we did it with integers and then we only did one quick example where we had square roots. So let's go ahead and talk about now an example with square roots and a second example with some complex solutions, some imaginary numbers. So here I've got two zeros. My zeros are -2 and square root of 3. But the conditions that are outlined in our question are that it has to have least possible degree with a leading coefficient of 1, and this is key, integer coefficients, which means there's no square roots that are going to pop up anywhere in our answer. So somehow we have to undo the square root that we're given in our problem. And we do that by using what we call the conjugate. And the conjugate just takes that same radical and it changes it to the opposite sign. So instead of positive square root of 3, I'm going to have a third zero of negative square root of 3. And now I go ahead and I create my polynomial with these three zeros. Now we need to go multiply all of this out. If you remember your difference of squares, that's going to help you simplify these two factors pretty easily. So let's go ahead and talk about that. So remember when we have two perfect squares and we're subtracting, that factors into the sum of the bases and the difference of the bases. So what we're going to do is we're going to notice that we have the sum and the difference of the same two bases, x minus rad 3 and x plus rad 3. So what I can do is take those bases and square them individually and then subtract them. So that's what I'm going to do to multiply those last two factors. So that product becomes just x squared minus 3. And then I still have that first factor of x plus 2 that I need to multiply. Now, if you're not comfortable with that process of using the difference of squares, you are more than welcome to just either use FOIL or distribute to multiply those two together. But I would definitely multiply these two together first before you bring in that x plus 2 because they do simplify really nicely and you won't have to deal with radicals for long. Now I'll go ahead and distribute my x plus 2. And put it in standard form. And this is our polynomial satisfying all the conditions above. Okay, let's do one more. Now in this one, we've got a slightly more advanced type of zero. I have 1 minus I as my complex zero. Well, I know that I is a form of a radical, and in order to make sure that that radical cancels out, I need to have the conjugate. And the conjugate is just the same expression where the radical component has the opposite sign. So instead of 1 minus I, I'm going to have a third zero of 1 plus I. And again, only that radical component changes to the opposite. So the 1 doesn't change. We don't touch that. We only change the I. And now I go ahead and I set up my polynomial using these three zeros. Now again, I highly suggest that you multiply the two that have those radicals in them first because it's going to simplify super nicely. And then after you multiply those two, we'll go ahead and we'll multiply by that first factor. So I'm going to multiply these two first. And we can still use that difference of squares trick that we used on the last one. We just have to be a little bit more creative. So in this one, I see that I have x minus 1 and I have I. And then in the second factor, I have another x minus 1 and another I. And notice that those two bases are being added and subtracted. So instead of foiling all this out or distributing to simplify, I can use my difference of squares. My first base is going to be x minus 1. So I take that x minus 1 and I square it. My second base is going to be the I. So I take the I and I square it, and then I subtract to create the difference of squares. So that's the shortcut to multiplying those two together. I'll continue simplifying. The x squared minus 1, if you remember your pattern of multiplying a minus b squared, we end up with a squared minus 2ab plus b squared. That's what I'll use to simplify this out. If you're not comfortable, just multiply the x minus 1 times x minus 1. Something we also need to remember is that I squared is just negative 1. So I'll go ahead and substitute negative 1 for I squared. Okay, so we have successfully multiplied out those last two factors in our polynomial. But now we need to go back and bring in that first one, which is that x minus 3. So this is the product of the last two, but the first one is x minus 3, and all of this creates my p of x polynomial. So now I'm going to take that x minus 3 and distribute it into that trinomial in the second factor. And I combine like terms. And this is my polynomial that satisfies the criteria I was given. Hope that helped. Thanks so much for watching, and I'll see you next time. Bye.